Ladies and gentlemen, personalities, how to plot trigonometric graphs. Let's say you are given a trigonometric graph and then you are supposed to plot it. So how do you go about and do that? I'm going to write steps here on the side, and then I'm going to use steps here. Right. So step number 1, plotting trig graphs. So step number 1, draw the axis. Okay, and then so here is the x, and then here is it, and then this is the y-axis, this is the x-axis, and then this is 0. All right. Okay, there's something that I forgot. They can't tell you plots y is equal to sine x and then they don't give you an interval. They will give you an interval and then they will say for x, let's say in this case they say for the element of 0 degrees up to 360 degrees. Okay, so step number 1, plot the axis. Right, so here are the axes, you have plotted them. Okay, so number 2, note the range. Okay, note the range and plot it. Okay, so what is the range? So how do you see the range? When you want to see the range, you look at the number that is here. Okay, the coefficient of sine x. The coefficient of sine x, because there is nothing here, there is an invisible 1. Okay, so the range here is what? So you've got the amplitude, which is 1. Because remember, if you've got y is equal to, the general formula for sine will be y is equal to a sine b x, right? And then in this case you've got y is equal to sine x. So that means that our amplitude here is what? Is an invisible 1, and then our b is also an invisible 1. So our amplitude will tell us about the range. So since our amplitude is 1, so what does that say about the range? That means that in this particular case, the range will be y is an element of from -1 up to 1. Okay, so this amplitude, which is 1, it tells you that the distance between 0 and the top point is 1, and at the same time the distance between 0 and the lowest point is what? Is 1 as well. So from here to here it must be 1. Okay, so I'm gonna put 1 here. Let's say we've got 1 here. Okay, and then here as well you're gonna have -1 here. Okay, so you're gonna have -1 here. So the distance between here and here is 1. At the same time, the distance between here and here is 1. Where did you take that distance from? You took it from the value of an amplitude, which is in this case an invisible 1. Right, so this number here tells us about the amplitude. If this number here is 2, therefore the distance from here to here must be 2. If this number is 3, then the distance from here to here must be 3, and then the distance from here to here it must also be 3. Okay, so it's going to be, it could be minus, it will then be -3 and 3. But now in this particular case, the amplitude is 1, so the distance from here to here is 1, and then the distance from here to here is 1. Okay, so we have noted the range, which is this. And then what did we do? We then plot it. So basically we're not necessarily plotting it, we are actually demarcating it. Okay, let's not say plot here, let's say demarcate. It's a very complicated English word. To demarcate is just to put a boundary. Demarcate. Okay, so there we go. And then you do exactly the same thing. Yes, in other words, you are showing that, okay, whatever graph that I'm going to have, it won't go above this one, above the x line, and then it won't go below this -1, below the x part. Okay, so that was number 2. Now what is number 3? Number 3 is a domain. Note the domain, the domain, and demarcate it. Demarcate it. Okay, now where do you find a domain? You always find a domain with the graph itself. Okay, what is a domain? The domain are the values of x where this particular graph will be working. In other words, this graph, in which values of x will it take? So it takes the values of x from 0 degrees up to what? Up to 360 degrees. So 0 degrees is here, 360 degrees, let's say it's somewhere here. So we'll just say 360 degrees, and then we need to demarcate. Okay, so that is step number 2. So what is step number 1? Just to go back, we plot the axis. You just plot the x-axis and then y-axis and then the 0, and then you label it. That is number 1, and it's for free. And then number 2, you note the range. In other words, you go and look at your amplitude so that you can find the range. And then when you have found the range, then you need to do what? You need to demarcate it on the graph. Now, when you have found the range, the third thing that you do is to do what? Is to note the domain and then demarcate it. So now you know. I do not know what kind of a graph I'm going to have, but I know that this graph is going to fit somewhere into this small rectangle that I have. Okay. Wonderful. So what is step number 3? Step number 4. Step number 4, find intervals. Okay. Find the interval. So how do you find the interval? You use a formula that says intervals, not just intervals of what? It's x intervals. Find x intervals. Just say x intervals. So x intervals. Remember, it's not intercept, it's intervals. You take a period, whatever the period is, and then you need to divide it by 4. This is what you always do when you are finding the x intervals of any trigonometric graphs. Okay, so what is P? P is a period. Now, what is a period? A period is how many degrees will it take for a complete cycle of trigonometric function to complete itself. Okay, that is what a period is. How many degrees will it take for sine to complete itself or to go a full cycle? Okay, we'll explain that in details when we explain the different parts of graphs. Okay, so for sine theta and cos theta, period is, let's just write in. Okay, for sine theta and for y is equal to sine theta and y is equal to cos theta, P is equal to what? Is equal to 360 degrees. Okay, if you've got sine theta like this in this one and like this one. Okay, and then if you've got y is equal to tan theta, your P will be 180 degrees. Okay, so we are talking about sine x here. So the period will be what? Will be 360 degrees. So you take this period and you divide it by 4, and then you will get the x intervals. So for x intervals, in this particular case, you're going to say what? You are going to say P over 4, which is 360 degrees divided by 4, and this will give you what? 90 degrees. Okay, so the intervals are 90 degrees. Okay, so you must just demarcate here. So now when you find the interval, so find the intervals and then what? And then demarcate them. Okay, so let's say, okay, let's try to put this thing nicely. You must write nicely, not like me. So let's say here there is, okay, so this is 90 degrees. 90 degrees. This is the first interval. Second interval is going to be 180 degrees, because 90 plus 90, you know, yes. And then 180 degrees plus 90 is going to be what? It's going to be 270 degrees. And then 270 degrees plus 90 is going to be 360 degrees. So we have done step number 4. All right. Now, number 5. What do you do? Step number 5. So what you do in step number 5, you then find connecting points. Connecting points. So how do you find connecting points? So you take the intervals as they are, and then you plug them on the equation. This equation, which is y is equal to sine x. And then you will get the value of I associated with it, and then you will put it on a graph. Okay, now let's do it together so that you can see how we go about doing this. Okay, so okay, the first one is 0. Okay, let's say sine 0. Sine 0 is equal to 0. And then guys, remember, your calculus must be in degrees when you're doing this thing, okay? Because if it's not in degrees, then you'll get something else. Okay, so sine 0 is what? Is 0. So you mark 0. Aha, this is your first point. Okay. Okay, let's continue. What is the next point? The next point is 90 degrees. Okay, let's just put something here just to show. Okay, so sine 90 degrees. Aha, you get what? You get 1. Where is 1? 1 is here. So this is 90 degrees, this is 1, this is where they meet. Then put a point there. There is your second connecting point. Okay, the next connecting point is what? Is sine is 180. So sine 180 degrees. Some of you already know what's going to come out. Yes, it's what? It's 0. So where 180 degrees meets 0, it's here. So you've got another point here. Okay, now the next one is 270 degrees. So sine 270 degrees. Can you see? It's minus 1. Where is minus 1? Here is minus 1. Where do they meet 270 degrees? This is where they meet. Aha, there we go. It's here. And then just put this little circle here. And then the next one is 360 degrees. And then you just say sine 360 degrees. You get 0 again. So this is where they meet. Okay. So you find the connection points. So you found these connecting points. And then what is the next thing to do? So what you then do, step number 6, you then connect the points. Okay, so here are the points, just connect them. There we go. There we go. Now, after connecting the point, step number 7, what do? You label the graph. Okay, so when you label the graph, you say this is y is equal to sine x. So this is the name of this graph. Okay. And then what you then do, you then label the intercepts and turning point. Okay, so this is the first intercept. And then so here you've got 0 degrees. And then you've got 0. Okay, and then here you've got what? The x part, there is 90 degrees. And then there is 1. What about here? You've got 180 degrees. And then the y point there is what? Is 0. And then what about this one? In the x point, you've got 270 degrees. And then y point is what? It's -1. And then lastly here, you've got 360 degrees. And then the point is 0. Okay, therefore you are done. You now have a graph of y is equal to sine x. Right? Is that difficult? No, it is not difficult. Okay, so this is basically how you go about to draw the sine graph. Okay, what about the cos graph? Follow the same steps. Let's say you want y is equal to cos theta so let's say x for continuity's sake. So it's y is equal to cos x for x, which is what? Which goes from 0 degrees up to 360 degrees. Okay. Steps are exactly the same. Draw the x-axis. There is your x-axis. This is x. And then this is y. And then this is 0. Okay. Step number 2, note the range. Amplitude is 1 here. So the range is also 1. Distance from here to here is 1. And then the distance from here for here is also 1. Okay. So we've got 1 here as well. And then you need to demarcate it. Demarcated it. Okay, you note the domain and then you need to demarcate it. Where is the domain? 0 and 360. There is 0. 360 is somewhere here. You also demarcate it. Okay. Next, find x intervals. X intervals is equal to p over 4 and then p x intervals is equal to p over 4, which is equal to 360 degrees over 4, which is equal to 90 degrees as well. So from here to here it's 90 degrees, and then this is 180 degrees, and then it's 270 degrees, and then the last one is 360 degrees. All right. Step number 4 done. Step number 5, find the connection points. Now I want you to look at these connection points very strongly. The first one is 0. You take the intervals where they start up until where they end. So cos 0, 1. So where is 0 and 1 meet? They meet here. Then the next one is 90 degrees. So cos 90 is equal to 0. So here's a point. Let's put circles as we did earlier just for consistency. And the next one is 180. It's cos 180 degrees. It's minus 1. So 180 and minus 1 here is where they meet. And then the next one is 270 degrees. Cos 270 degrees. And then it's 0, so it's somewhere here. And then lastly, it's what? It's 360 degrees. So cos 360 degrees is equal to 1. So here is 1. Okay. You did find a connection point. Connect the point and then label them. Okay. When you connect these points, get something like this. Okay. Get something like this. It looked like, can you see what it looked like? It looked like the bicycle horns. Can you see? This one looks like S that is just standing in its own way, and then this one looks like bicycle horns, or the horns of a cow or a goat or something like that. Okay, that is y is equal to cos x. So that is basically how you go about writing y, and then is equal to cos x, right? And then the last one is the tan graph. How to go about plotting the tan graph? It's just very the same. It's y is equal to tan x for x, which is an element of 0 to 360 degrees. Okay. Now, the first step, draw the axis. Here are the axes. This is a y, and this is an x1, and this is 0. Okay. And then note the range. Okay, now when it comes to tan theta, in tan theta, there's no range. Let's make that note NB. Not that there's no range. The range of tan theta is what? Is y is an element of real numbers. That means that there is literally no range. So along y, the graph goes up to a positive infinity and up to a negative infinity. Okay, so there are no limits. Okay, so it's only the domain that we must note in this particular case. Okay, now the domain is 360, so we're gonna have 360. 360. Okay, and then we need to find the intervals. So the intervals here, we're going to say p. Remember, we said p is 180. So x intervals is equal to p over 4, and then we've got p, which is 180 degrees divided by 4. And then what is 180 divided by 4? I think it's 45. Let's check. Aha, I'm right. It's 45 degrees. Okay, so the intervals are going to be 45. So, okay, this is 90, this is 180, and then 270. Okay, so 0, and then 45 is going to be a 45 degrees. And then 45 degrees plus 45 is going to be 90 degrees. And then plus 45, going to have 135 degrees. And then plus 45, you will then have what? You're going to have 180 degrees, and then plus 45. So here you're going to have 225, and then plus 45, you're going to have 270 degrees, and then plus 45, you're going to have 315, and then plus 45, you're going to have 316, and then all of these things are degrees. Okay. So it seems as if when it comes to tan, we've got what do they call these things? We've got their own set of rules. So rule number 1, plotting. So basically these steps works very well when you're only plotting what? Sine theta n and cos theta. So when you're plotting y is equal to tan theta, it's different. Okay, so let's say this one is plotting graphs, but we are referring to y is equal to sine theta and y is equal to cos theta, right? When we are plotting y is equal to tan theta, so what do we do? Number 1, we do the same thing, draw axis, and then number 2, find intervals. Okay. Find intervals. And then what do then do after that? Number 3. Okay, so when you have found intervals, guys, you must find the connection points. You still find connection points even with this one. Find connection point. All right, so when you found, okay, now in this case, let's simply do this, ne? Okay, in this case, here is 1. Okay, this is -1, and then this is 1. Okay, remember I said there is no range. Range is y is an element of real numbers, which means all real numbers are part of the range. Okay, so now I want you to be very careful when we are plotting this. Okay, we're going to be checking numbers one by one. Now I want you to look at this and look at it properly. So let's start with the first one. It's 0, tan 0. Tan 0, we get 0. So here's the point. The point is here. Okay. Okay, now there's tan 45. Because there's 45, I can see. Let's say tan 45. What do we get? We get 1. So there is 1 here. Can you see that? That is where 45 meets and 1. Okay. Okay, and then tan 90. Let's check tan 90. Tan 90 degrees. Guys, can you see what is happening? It's math error. Okay, so what does math error means? It means that there is no solution in this regard. So if there's no solution in this regard, what does that mean? It means that at 90 degrees you've got an asymptote. So now we are introducing something. So while we are finding connection point, you need to identify. Let me not say this is 4. Let me just put it here. Identify asymptotes. Now, what are asymptotes? Asymptotes. What are asymptotes, guys? Asymptotes sounds like a very fancy English word. Asymptote is something simple. It is a line. But what kind of a line it is? It is a line that the graph comes close to but never touches. Right. It will come close to, but it will never touch. Okay. So here we've got that line. Now when you have an asymptote, you must always demarcate it as well. Okay, find asymptotes and demarcate them. Demarcate them. Right. Right. So you know that whatever graph that you write or you plot or you draw, whatever you want to call it, I don't care. You know that the graph will come close to this line, but it will never touch it. Okay. Let's continue. The next one is 135 degrees. Let's go and say tan. Can you see? Must I bring it close? Tan 135 degrees. What do we get? We get minus 1. So minus 1 is where? It's here. So here and here. Aha, can you see what is happening? There is some point here. Okay, tan 180 degrees. Let's see. Tan 180 degrees. Get 0. So there is another point here. Somewhere here. Can you see there's a point here, there's a point here, there is no point here, there's a point here, and then there's a point here. Okay, the next one is 225. So tan 225, what do we get? We get 1. Okay, tan 225 degrees. So where is this 225 degrees? There is 1. So 1 is here. Let's put it here. Okay. And then tan 270. The next one is 270. Can you see? Let's say tan 270. Tan 270. Math error. That means there is an asymptote as well at 270 degrees. So now, guys, when we represent the asymptotes, we always present them with a broken line. Okay, and please write them nicely. Don't write it like myself. Remember, I passed my maths. I did my high school. So don't look at me writing nonsense and then you must also write nonsense. Write it nicely. Okay, presentable. Alright. The next one is 315. Let's see. Tan 315. What do we get? Minus 1. So there is a point here. And then lastly, tan 360. Can you see? It's 0. So it's here. Okay. Can you see that? So here are our points. Let me put nice color so that you can see them properly. It's this one. 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 And then it's this one. Okay. So whatever graph that we write, it must pass around those points. Okay. So how do we continue? So what do we do? Okay, so when we plot, so what we simply do is we try above the x-axis, we try a curved correct. Okay, we go like this. Okay, can you see? It's a curve correct. Okay, so but whenever we reach this point, we then start curving. Okay, So, for example, here, we'll go like this. We'll try to. Okay, this thing has not been drawn to scale. So we'll try to correct ourselves. And then, can you see? And then we'll do the same thing here. As if you are writing correct. You know the correct that you, like the one that you draw, like yes, but a curved one. And then there's no, this part is not there. Okay. So you will do the same thing and then, can you see? Can you see? Aha. Remember, you'll go close to this line. So on the upper side, it's a curve, correct? But now from the X line to below, you will then do things like this one. Okay, can you see? It's like a skewed bracket or whatever in a way. Okay, so here you're gonna connect it here. And then you're going to say, and then when you reach here, you then try to reach this line. Can you see? And then you do the same thing here. It's coming from this one. And then you go like this. And then when you reach here, make sure you start, you know, we must see things skewing from here to here. Okay. So this is your graph. You label it. This is y is equal to tan x. Okay. So this is our graph of tan x. Now I want you to note something. Remember, our domain was from 0 to 360 degrees. If our domain was going to be above 360 degrees, we would have continued with this correct here, so that it stands exactly like this. And then there will be some sort of an asymptote here. In the same way, if it was continuing on this side, you would have also extended this line. But we are only interested from 0 degrees to 360 degrees. So that is why we're going to stop here. All right. But don't worry. These graphs are not complicated. You will actually get them. They are very easy. Just use them. So you identify the asymptotes and you demarcate them. And then number 4, you plot. You plot and label. Okay. So that is how you plot y is equal to tan x. Okay. So next time when we speak, we are going to speak about transformation of these graphs. How do they transform? How do they shift up? How do they shift down? And all of those kind of things. But for today, let us end it here. So ladies and gentlemen, this is how you go about and plot the graph of sine theta, the one that you draw here, and then the sine of cos theta, the one that you draw here, and then the graph of y is equal to tan theta. Ladies and gentlemen, personalities, thank you very much for tuning in. My name is Mkondes Makaba from Tsembela Maths Club, a club that helps learners to understand mathematics. Have a lovely day, and if you've got any questions or something that you do not understand, please do not feel shy to ask in the comment section. Thank you very much and goodbye.